Imagine a jet you can land at a gas station in the middle of nowhere. This is the magic of short takeoff and vertical landing, or STOVL, fighters. STOVL fighters transform the strategic landscape, enabling forces to project air power from virtually anywhere. Whether supporting troops in rugged terrain, enhancing naval operations, or operating from makeshift bases in conflict zones, these jets redefine the possibilities of modern warfare, showcasing the pinnacle of aviation engineering and innovation. Let's take a closer look at these remarkable machines. This aircraft is from the first V-STOVL fighter jet family, meaning that 22,000 pounds of thrust enable it to hover like a helicopter and then blast forward like a jet at near supersonic speeds. And even though it is subsonic and not designed as a fighter, the first generation of this aircraft saw dogfight action during the Falkland War and held its own against Argentine's Mirage jet fighters. Then it came to America, got a huge upgrade, and continued its trial by fire. During the 42 days of combat of Operation Desert Storm, it flew 3,380 combat sorties and delivered more than 6 million pounds of ordnance. So, it became a movie and TV star. Back in the 90s, this aircraft cost almost $30 million, or 7 million Pepsi points. The AV-8B Harrier II was developed by a team comprised of McDonnell Douglas, British Aerospace, and Rolls-Royce. It was based on the 1957 British-designed Hawker Siddeley Castrol. However, it went through a series of extensive upgrades. The technological advances incorporated into the Harrier II significantly reduced the workload on the pilot. And to improve visibility and better accommodate the crew and avionics hardware, the cockpit was elevated by 10.5 inches and the canopy was redesigned. The Harrier II is the first combat aircraft to employ composite materials extensively. They are used on the wings, rudder, flaps, nose, forward fuselage, and empennage. In total, 26% of the aircraft's structure is made of composites. The AV-8B, built in St. Louis, Missouri, first flew in 1981, and over 340 Harrier IIs were built. For more than 3 decades, the AV-8B Harrier has been a workhorse of the US Marine Corps. The Harrier II HV-8B is an attack aircraft with some really cool characteristics. It has horizontal stabilizers and shoulder-mounted wings with prominent anhedral or downward slope. The aircraft is propelled by a single Rolls-Royce Pegasus turbofan engine, which has 2 intakes and 4 synchronized vectorable nozzles close to the turbine. 2 of those nozzles are near the engine's forward cold end, while the other 2 are near the engine's rear hot end, while the majority of fixed-wing aircraft have their engine nozzles at the back. To provide control at low airspeeds, the Harrier II also has smaller, valve-controlled nozzles in the nose, tail, and wingtips. With the help of its unique nozzles, Harrier II can perform a special air maneuver called viffing, that is, making radically tight, controlled turns. The AV-8B has one fuselage centerline and 6 wing hardpoints, apart from 2 fuselage sections for a 25mm GAU-12 equalizer cannon and ammunition pack. This 5-barrel cannon is based on the mechanism of the GAU-8A Avenger cannon, but fires a new NATO series of 25mm ammunition. Its rate of fire is normally 3,600 rounds per minute, with a maximum of 4,200 rounds per minute. That is some serious punch, but it doesn't end there. The hardpoints enable the aircraft to carry a total of 9,200 pounds of weapons, including air-to-air, air-to-surface, and anti-ship missiles, as well as unguided and guided bombs. It can achieve a speed of 633 miles per hour. The 7,500-pound internal fuel capacity of the plane can be increased by using hardpoint-compatible external drop tanks, giving the aircraft a maximum ferry range of 2,100 miles and a combat radius of 300 miles. The Harriers were supposed to be retired, but the F-35's delays and a review that not only altered how the Marines used the Harrier, but also revealed that the airframes still had a lot more flight time in them than had been previously believed, gave them a second chance. Due to this, the Marines sought for enhancements for the Harrier force, such as more recent AMRAAM missiles and the 500-pound GBU-54 laser joint direct attack munition, which combined GPS guidance and a laser seeker. The Harrier looks like it will be around for a while, even as the F-35B Lightning II, the VSTOL version of the Joint Strike Fighter, enters service. In the ever-evolving theater of modern warfare, where adaptability and technological prowess reign supreme, the F-35B Lightning II emerges as a game-changer. This 5th-generation stealth fighter, a marvel of engineering, isn't just another jet. It's a versatile weapon platform that can rewrite the rules of engagement. Born from the ambitious Joint Strike Fighter program, the F-35B was conceived to replace a multitude of aging aircraft across different branches of the military. Its defining feature? The ability to perform short takeoffs and vertical landings, a capability known as STOVL. This unique trait opens up a world of possibilities, allowing the F-35B to operate from smaller ships, austere landing strips, and even damaged runways. Picture this: a sleek, angular fighter jet launching from a compact fighter carrier deck, not with a roaring takeoff run, but with a controlled vertical ascent, its powerful engine and innovative lift fan system defying gravity. The F-35B isn't confined by traditional limitations. It's a force multiplier that can project air power from places previously deemed inaccessible. The F-35B, with its sleek and compact design, measures 51.2 feet in length, boasts a wingspan of 35 feet, and stands 14.4 feet tall. Its wing area of 460 square feet contributes to its impressive lift and maneuverability. The The heart of the F-35B is the Pratt & Whitney F135PW600 turbofan engine, a technological marvel in itself. This powerful engine produces a staggering 43,000 pounds of maximum thrust, propelling the aircraft to supersonic speeds of Mach 6.1. However, the F-35B's defining characteristic lies in its STOVL capability, achieved through a combination of the engine's unique 3-bearing swivel module and a Rolls-Royce lift fan. This innovative system generates an additional 20,000 pounds of thrust, enabling the F-35B to take off in remarkably short distances and land vertically. The Rolls-Royce lift fan is a sophisticated and integral component of the F-35B's short takeoff and vertical landing, or STOVL, system, providing the necessary lift for vertical takeoff and landing operations. Manufactured by Rolls-Royce, this lift fan boasts a fan diameter of 50 inches and produces approximately 20,000 pounds of thrust, all while weighing around 1,700 pounds. The lift fan's configuration includes a counter-rotating fan and an axial flow compressor driven by a shaft connected to the low-pressure turbine of the Pratt & Whitney F135 engine via a clutch and gearbox system. This shaft-driven system ensures the lift fan operates at the required speed for vertical lift. One of the lift fan's unique features is the 3-bearing swivel module, or 3BSM, an exhaust nozzle at the rear of the F-35B that can rotate 90 degrees downward to direct engine thrust forward, working in tandem with the lift fan to achieve vertical lift. Additionally, auxiliary nozzles known as roll posts on the wings provide extra stability and control during vertical takeoff and landing. The system also includes inlet and exhaust doors that open to allow air into the lift fan during vertical operations and close during conventional flight to maintain stealth and aerodynamic efficiency. The lift fan uses advanced materials such as titanium and composites to withstand high temperatures and stresses while keeping weight to a minimum. Its cooling system includes mechanisms to manage heat generated during vertical lift operations, ensuring the component's longevity and reliability. Integrated with the aircraft's flight control system, the lift fan's operation is precisely managed to provide seamless transitions between vertical and conventional flight modes. This advanced design and engineering enable the F-35B to perform operations from short runways and amphibious assault ships, making it a versatile and invaluable asset for military operations. The F-35B's performance is equally impressive. With a combat radius of approximately 505 nautical miles on internal fuel, it can reach a service ceiling of over 50,000 feet and has a maximum takeoff weight of 60,000 pounds. Its impressive range, exceeding 900 nautical miles on internal fuel, allows for extended missions without the need for aerial refueling. But the F-35B is more than just its STOVL capabilities. It's a stealthy phantom, its radar-evading design making it nearly invisible to enemy sensors. It's a digital hunter equipped with advanced avionics and a cutting-edge distributed aperture system, or DAS, that provides the pilot with a 360-degree view of the battle space. It's a multi-role warrior, capable of air-to-air combat, ground strikes, and electronic warfare, all within a single airframe. The F-35B is a potent weapon platform. Its arsenal includes the internal GAU-22A 25mm 4-barrel rotary cannon for close-in engagements, 2 internal bays capable of carrying a variety of air-to-air and air-to-ground munitions, and 6 external pylons for additional weaponry or fuel tanks. This diverse armament, coupled with its advanced sensors and targeting systems, makes the F-35B a formidable adversary in both air-to-air and air-to-ground combat. At the heart of the F-35B's technological prowess is the Integrated Core Processor, or ICP, a powerful computer system that serves as the brain of the aircraft. The ICP manages the vast array of sensors, avionics, and mission systems, seamlessly integrating data and providing the pilot with a comprehensive and real-time view of the battle space. The F-35B's cockpit is a haven of cutting-edge technology. The AN/APG-81AESA radar, a state-of-the-art electronically scanned array radar, provides unparalleled situational awareness and target tracking capabilities. The Distributed Aperture System, or DAS, further enhances the pilot's situational awareness by providing a 360-degree view of the battle space. Other advanced systems, such as the Electro-Optical Targeting System, or EOTS, and Helmet-Mounted Display System, or HMDS, provide the pilot with critical information and targeting data in real time. The F-35B's low observable stealth, achieved through advanced radar-absorbing materials and design features, make it incredibly difficult to detect on radar. This, combined with its integrated electronic warfare suite for electronic attack, protection, and support measures, ensures its survivability in highly contested airspace. The F-35B is not without its critics, with debates over cost and complexity. However, its impact on modern air power is undeniable. It represents a paradigm shift in fighter design, a fusion of cutting-edge technology and operational flexibility, whether operating from a carrier deck, a remote outpost, or a damaged airfield. The F-35B is a force to be reckoned with, a testament to the ingenuity of human engineering and the relentless pursuit of air dominance. This concludes our episode that provides a glimpse into STOVL fighters. So what do you think about these fascinating aircraft? What other pieces of military hardware would you like us to cover in our future episodes? Also, if you were lucky enough to see one of the aircraft mentioned in this video up close, or better yet, fly one, please comment. Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.